Okay, in this video I want to talk about evaluating the trigonometric functions when you're evaluating them for values outside of the interval 0 to 2 pi. So we're going to do sine of 15 pi over 6, cosine of 33 pi over 2, cosecant of 19 pi over 3, tangent of negative 21 pi over 4, secant of negative 47 divided by 6 pi, and cotangent of negative 103 pi divided by 4. I'm going to assume that you can evaluate the trig functions, sine, cosine, cosecant, tangent, secant, cotangent, at values on the interval 0 to 2 pi. If you cannot do those, that's definitely the first place you would want to start, because I'm going to refer to that, stuff quickly, and I'm not going to go all the way through it. So, okay, so assuming you're comfortable there, let's look at evaluating sine of 15 pi over 6. Okay, so the basic idea here is you want to write 15 pi over 6 as a mixed number. We're going to try to write 15 pi over 6 as a mixed number. And maybe you've forgotten, what is a mixed number? This is something we do, pretty early on in elementary school, and then we never even really do it again. So it's certainly reasonable that maybe you've forgotten this. So 15 pi over 6. I'm going to forget the pi for a second. I'm just going to think about 15 over 6. Well, to make 15 divided by 6 into a mixed number, we're just going to do long division. Okay, so we have 15 divided by 6. So I think, 6 goes into 15 how many times without going over? Well, 2 times. 2 times 6 is 12. We subtract and we get a 3. That's our remainder. So what this says is we can write 15 divided by 6. We can write this as, the number on top, which was 2, the remainder, which is 3, and then we put it over whatever we were dividing it by. So we can write 15 over 6 as 2 and 3 over 6, 2 and 3 sixths, and that reduces to, well, 3 divided by 6 will reduce to 1/2. So we can write 15 divided by 6 as 2 and 1/2. What we really mean when we write 2 and 1/2 is we mean that it's 2 plus another 1/2. That's what we mean when we write 2 and 1/2. They usually don't discuss this in elementary school when they talk about mixed numbers. They just say, hey, write it as 2 and 1/2. But this is what we're doing. We're saying it's the whole number 2 plus a half. That'll get you to the value 15 divided by 6. Well, likewise, 15 pi divided by 6, that's going to be 2 pi plus another 1/2 pi. Okay, so now to evaluate sine of 15 pi over 6, I'm trying to figure out where on the unit circle I would end up if I go 2 pi units plus another 1/2 pi units. Well, recall 2 pi, that takes you all the way around the unit circle. The distance around the unit circle is 2 pi. Okay, so we've gone 2 pi. If we go another 1/2 pi, pi over 2, that's going to put me right at the top of the unit circle. When I hit the unit circle at the top, that's going to correspond to the point 0, 1. So sine of 15 pi over 6, that's going to be the exact same value as sine of pi over 2, because it puts me at the exact same place on the unit circle. Well, sine of pi over 2, again, sine has to do with the y-coordinate. So sine of 15 pi over 6, or equivalently sine of pi over 2, that's going to equal 1. Okay, so the moral of the story here, and this is what I'm going to do in every example, I'm going to make it into a mixed number. I'm going to think about where does that put me on the unit circle, and then I'll get my value from that. Okay, so let's do the other ones. So part B was cosine of 33 pi divided by 2. So let me make 33 divided by 2 into a mixed number. Well, let's see. So 2 will go into 3 once. 1 times 2 is 2. If we subtract, we get 1. We drop down to 3. 2 will go into 2 will go into 13 6 times. 6 multiplied by 2 will be 12. I subtract, I get a 1. this is going to be my remainder. So it says that I can write 33 divided by 2 as 16, plus the remainder, which is 1, over whatever we divided by, which is 2. So okay, actually this one's going to look a whole lot like the example we just did. So likewise, 33 pi divided by 2, that's going to be 16 pi plus another 1/2 pi. So I think, okay, in terms of the unit circle, if I go around, 16 pi, okay, so there's 2 pi, 4 pi, 6 pi, another will give me 8 pi, 10, 12, 14, 16 pi. If I go around 16 pi, I'm going to be right here. I go another pi over 2, it's going to put me at the exact same place. It's going to put me at the top of the unit circle, which is going to correspond to the point 0, 1. So just like our, very much the same as our last example, cosine of 33 pi over 2, that's going to give me the exact same value as cosine of pi over 2, because ultimately I'm sitting at the same place on the unit circle. Well, cosine of pi over 2, I think, okay, at pi over 2, I hit the circle at the point 0, 1. Cosine has to do with the x-coordinate, so cosine of pi over 2 is going to equal 0, and that's my solution. All right, let's keep going through these. Part C, we've got cosecant of 19 pi over 3, and then we'll start looking at we'll throw in some negative angles. Okay, so 19 divided by 3, I'm going to make that into a mixed number. So let's see, 19 divided by 3. 3 won't go into 1, it'll go into 19, I guess, what, 6 times without going over? 6 multiplied by 3 is 18. If I subtract, I get a 1. That's my remainder. So it says I can write 19 divided by 3. That's going to equal 6. And another remainder of 1 divided by 3. So 19 pi divided by 3, that's going to be 6 pi plus another 1/3 pi. Well, we just looked at that. Same idea. If you go around an even number of pi's, it's always going to put you right back at sitting on the positive x-axis. So there's 0, 2 pi, 4 pi, 6 pi, etc. Then it says I need to go another 1/3 pi, or equivalently pi over 3. So pi over 3 is going to put you right there. And recall at pi over 3, the values on the unit circle, that was 1/2 comma square root of 3 over 2. Okay, so I'm saying, again, if we go around, if we find the angle on the unit circle that corresponds to 19 pi over 3, that's going to be the same thing as just going to pi over 3. Well, cosecant of 19 pi over 3, that's going to be the exact same thing as cosecant of pi over 3, because we're sitting at the exact same place on the circle. Well, cosecant is defined to be 1 over sine. So really this is the same thing as 1 over sine of pi over 3. Okay, so sine of pi over 3, I think, okay, so again, sine has to do with the y-coordinate. At pi over 3, the y-coordinate is the square root of 3 over 2. If you have 1 divided by a fraction, you just flip the fraction, you're going to get 2 over the square root of 3. On a quiz or a test, personally, I would be fine with that. 2 over root 3 would be a perfectly acceptable answer. Some of you may have instructors out there that want you to rationalize the denominator. Well, to do that, we could multiply the denominator by root 3, the numerator by root 3. On the top, you would just have, well, 2 times root 3, there's nothing to simplify. The square root of 3 times the square root of 3, that's going to give you the square root of 9, which is just 3. So your solution in this case would be 2 times the square root of 3 divided by 3. Okay, let's jump on to the negative ones. Again, I made all of these at random. Hopefully some of these will give us some slightly different values. Let's look at tangent of negative 21 pi divided by 4. So I'm going to do the same thing. Okay, so there's a negative. We'll throw that back in there in a second. I'm going to just think about 21 divided by 4. Well, let's see. 4 goes into 21 5 times. 5 multiplied by 4 is 20. I subtract, I get 1. That's my remainder. So negative 21 over 4, it says I can write that as negative, well, let's see, it went 5 times plus another 1/4 times. So if I put a pi in there, that's going to correspond to negative 5 pi plus another negative 1/4 pi. Okay, so you can imagine distributing the negative. Okay, so what does that mean to do? Okay, so recall that negative, when we have negative values, we actually go clockwise. So there's negative 1 pi. There's negative 2 pi. If I keep going, that'll correspond to negative 3 pi, negative 4 pi, negative 5 pi. I'm going to be sitting right here. I'm going to be sitting along the negative x-axis. But now I need to go another negative 1/4 pi. So again, the negative just means keep going clockwise. So this negative says keep going clockwise. It says go another pi over 4. Okay, another pi over 4. That's going to take me halfway to the top. So okay, if you go around a couple times, I'm going to be sitting right there on the unit circle. Okay, so there's my circle. This is going to be the exact same place as if this angle is going to be the exact same place as if we had gone positive 3/4 pi. That's going to put me at the exact same place. So I would say that tangent of negative 21 pi over 4, that's actually going to be the exact same value as tangent of 3 pi over 4. Okay, because again, they put you at the exact same place on the unit circle. So let me think about my circle. Let's see, at pi over 4, I remember that it's positive root 2 over 2, positive root 2 over 2. The only thing that's going to change when you're sitting at 3 pi over 4, or equivalently, the angle, negative 21 pi over 4, the only thing that's going to change is, well, now the x-coordinate's going to be negative, so we'll have negative root 2 over 2, comma, root 2 over 2. Okay, so tangent of 3 pi over 4, or equivalently, tangent of negative 21 pi over 4. I'm going to use this one because it's probably more familiar to most of us. Recall that tangent is defined to be sine over cosine. So we take sine of 3 pi over 4, divide it by cosine of 3 pi over 4. Well, sine again is the y-coordinate. That's going to be root 2 over 2. Cosine of 3 pi over 4 is going to be negative root 2 over 2. I have a positive divided by a negative. That's going to give me a negative. I have the same number on top as it's the same number on the bottom. If you have a number divided by itself, that just gives you 1. So tangent of negative 21 pi divided by 4 is going to equal negative 1. Okay, I can hear what you're saying out there. You're saying, Patrick, I'm having a good time. Can we do 2 more? And yes, let's do 2 more. So negative 47 pi divided by 6. Okay, so I'm going to do 47 divided by 6. Okay, let's see. 6 goes into 47 how many times? 6 times 7 is 42. 6 times 8 is 48. That's too much. So it looks like 6 times 7. That's going to give me 42. Then I subtract 47 minus 42 is going to give me 5. That's going to be my remainder. So negative 47 pi over 6, I can write that as, so let's just think about the 47 over 6. I'm going a little faster here because we keep doing the same thing. 47 divided by 6, we said we can write that as 7, and another remainder, which is 5 over 6, because that's what we're dividing by, pi's. If I distribute that, I would get negative 7 pi plus another negative 5 over 6 pi. Okay, just like before, if you go around an odd number of pi's, here's negative 1 pi, negative 3, negative 5, negative 7. I'm going to be sitting right here. Now I think I need to go another 5/6 pi's. Well, okay, 6 over 6 would be a whole, that would be 1 pi, which would take me all the way. So if I went 6 over 6, that would take me all the way. So if I go 5 over 6, but again, I'm going clockwise because it's negative, it's going to put me right here on the circle. Okay, so my argument is that secant of negative 47 pi divided by 6, that's going to put me at the exact same place on the unit circle, and it's going to give me the exact same value as secant of pi over 6. Okay, so again, I went negative 7 pi around, that's going to put me here. 6 over 6 would take me all the way, but I need to go back pi over 6 to be sitting right here. So secant of pi over 6, if you think about the angle pi over 6, that's root 3 over 2, comma 1/2. If you'll recall, secant is equal to 1 over cosine. So secant of pi over 6, that's going to be 1 over cosine of pi over 6. Well, again, cosine is the x-coordinate, which is going to be root 3 over 2. So I have 1 divided by root 3 over 2, 1 divided by a fraction, you just flip the fraction. 2 divided by root 3, we just saw a second ago, you can multiply top and bottom by the square root of 3. That'll give you 2 times root 3 over 3 if you rationalize the denominator. So all of my examples are putting me on the top half of the circle, and again, that's just because I made these at random. Maybe the last one won't, let's see what happens. So the grand finale, cotangent of negative 1 over 103 pi over 4. So again, this looks maybe a little daunting when you first see it. You're like, that's a big number. You're going to get either, an odd number of pi's or an even number of pi's, and then you just go the remainder of the distance. So let's do 103 divided by 4. Well, 4 will go into 10 twice. 2 times 4 is 8. Let's subtract. So 10 minus 8 is 2. Let's drop down to 3. 4 will go into 23 5 times without going over. Let's see, 5 times 4 is 20. If we subtract, we get 3 as our remainder. So it says I can write negative 103 divided by 4 pi. Well, it's going to be a negative, something involving pi. It's going to be 25 and another 3/4 pi. So okay, I'm going to, again, if you distribute, and we'll multiply everything by pi, that'll be negative 25 pi plus a negative 3 pi over 4. Okay, so in terms of the circle, again, negative 25 pi is going to put me along the negative x-axis. Then I needed to go another 3/4 of a pi. Well, 3/4 of the pi, 4 over 4, would take me all the way around. But I need to backtrack 1 so that I'll be at 3. I'll end up with my 3 pi over 4. And again, the negative, that just indicates we're going clockwise. So there's my negative 25 pi. It's going to put me right there. I go another negative 3/4 pi. That's going to put me right there. It's going to put me right in the middle of the unit circle in quadrant 1. So cotangent of negative 1 over 3 pi divided by 4, that's going to be the exact same value as cotangent of pi over 4. Okay, well, again, at pi over 4, that's root 2 over 2, root 2 over 2. So tangent is sine over cosine. Cotangent is defined to be cosine over sine. So since we're doing it at pi over 4, we'll have cosine of pi over 4 divided by sine of pi over 4. Well, cosine of pi over 4, that's the x-coordinate, which is root 2 over 2. Ditto for sine of pi over 4, that's going to be the y-coordinate, which is also root 2 over 2. Any number divided by itself is going to give you 1. So the value of cotangent of negative 103 pi divided by 4 equals 1. So a couple skills here, again, being able to make mixed numbers, being able to find values on the unit circle, and then also just knowing the basic unit circle on the interval 0 to 2 pi. So none of mine put us on the bottom half of the circle, so that's just how it goes. My examples didn't work out that way. But the exact same reasoning works. So as always, feel free to post comments or questions. I get so many I can't necessarily help everybody that posts a comment or a question, but try to help each other out there. I'll appreciate it. So will your fellow student trying to make sense out of this stuff. So I hope it makes some sense, and good luck.